Hello, welcome. Today we will discuss about this proposal of an experiment to reveal interactions between gravitational and electromagnetic forces. Of course, it is not a way to unify forces in any ways. We are not properly unify electromagnetic and gravitational forces. We shall see in detail this at the end, but it's a way in which we can show, in which we can something like possibly reveal possible interaction between electromagnetic and gravitational forces. In detail, we shall focus on a book I wrote, a critical discussion about gravitation that is critical because it starts from a critical view of the gravitation, of the general special course in General Relativity, and it gets clues, it focuses on clues that can point that there is a medium, what they call a frame, another like medium is something where reasonably electromagnetic and gravitational forces may interact. So we shall first consider the theory, we shall then consider experimental clues, of course, and then propose the experiment. First, some can say forewords. How does physics work? It's based, as we were outlining, on theory, experimental evidences, of course, that turn around the mind of the researcher. Then the researcher elaborates a model based on this comparison between electromagnetic and gravity, based on theory and experimental results. He elaborates a model. A model, of course, is something that stays as it is. That should be falsifiable, as for Karl Popper says, in the sense that a model must be something that could be verified, could be falsifiable, in the sense that it could be checked not to be true. And as long as a model is something put in the air, you know, as Liz Morning was advising about the theory. Nicht einmal falsch. Nicht einmal falsch. Not even true. Not even false. A theory that cannot be falsifiable, could be true as false, is not a theory. It's something is a theory. I mean, it's a theory that brings to nothing, that not brings to any experimental evidence, that does not bring to any conclusion. Is just something, you know, string theory. Liz Morning, of course, refers to the string theory. It's something like considers words of 11 or more dimension, n dimension, whatever. Something that could be not falsifiable, that could be not checked to be true or false, simply because it cannot find an experiment that really verifies if it is true or not. Simply, it's a theory that can be modulated via thousands of parameters, via thousands of variables. It could be a theory that can be tuned to resemble another theory, but that cannot bring to a conclusion where I can verify by an experiment, yes, it's something adding value, is something not. So the comparison between modeling and experimental evidences brings the physicist to propose new probing experiments, as we will do at the end of this presentation. New probing experiments are those that can really grant the validity of theory. Some other forewords. What we use in this comparison between theory and experimental evidences is something that Manzoni Alessandro Manzoni, more than the introduction of chorus, so famous among the intellectual community, insert the technique of flashback. Referring to what? In chapter 11 of Promiscuous Posit, he was referring to a guy, a little guy, chasing guinea pigs. And he is observing, Manzoni was observing, that this guy will never be able to chase all the pigs at the same time. He has to choose one pig at a time, save it, and then chase another one. So go back, flashback, go back to the battlefield, and then chase another one, and then put it back. So all in this way, considering one thing at a time, and sometimes flashing back on what we already considered, we can get some results, more in detail. Let's talk about another book I wrote, unfortunately in Italian. I will translate this as I will first compile a new book about the full theory of the standard model of theory of fields, and then I will translate this book in English. It's a book that I do below, because it's a book that contains a lot of theory, reflection, ideas that I elaborated since 2000, since much more early, since 1986 up to 2010. More theories are as well are a bit advanced in 2010. And essays that you can as well play with and get fun for this. Mathematical political theory, in the sense that I use a math to get fun, to play, instead of finding something so boring. Oh, a general advice: this presentation is quite long. I am excused in advance, but contains the description of this book and others. There is 600 more pages, almost 650 pages. So it won't be short. I want to detail it, and so I don't know if I will be able to do all the presentation in one shot. And I recommend you to consider all to see part by part, or to check all the parts that you could be interested in. But anyways, it's quite long, and I'm sorry for it. So, what it says containing that, there is an essay, La piramide dell'intuizione, the pyramid of intuition, of deduction. So to me, this essay is quite important. It was the first I wrote. I don't know if I read it in '86 or so. But anyways, it's a very important essay to me, that describes how the brain works, in the sense how from scratch, from evidences, we can get a result. So that's why pyramid. In particular, we are talking about a concave pyramid, a pyramid like the Dante cell, with its vertex at the bottom instead of on the top. In the tail. Let's imagine an intuitive process. So we start from experimental data, we get to a result. Let's say that we have until like 15 experimental data, just as an example. To get a final synthesis, I have just to synthesize all these elements to a synthesis. Only there are two main reasons for this cannot be true. First, that does not exist on Earth a person so intelligent to be able to relate 15 elements at the same time. The second true reason, much more important than the first to me, is that those data are not available at the same time. They are distributed with time. So we could imagine, forget about the numbers, just as reference. We could imagine that, as for the atomic bomb, no? How we could get, just to carry on an example, how we could get to the atomic bomb. The atomic bomb starts from the very fact of special relativity, describing special relativity, that The speed of light and it's an insurmountable speed for whichever medium, for whichever as well massless body like a photon moving in space. So how can we arrive from this observation that of course was carried on not earlier than 3 or 4 centuries ago, so it was not immediate, it was not something dating to the Stone Age. Nonetheless, it was the basic information from which Einstein began to elaborate his Einstein or someone else began to elaborate his theory of special relativity. So what? Let's see in detail how we can arrive to the finite synthesis from a series of factors distributed with time. For example, for the atomic bomb, here on the top, and then the pointer does not point on the screen. So here, the first observation of the unsurmountability of the speed of light. You could imagine here the discovery of distributed in the time, the discovery of relativity, the blender, the discovery of blender. Here, or here, the first experiences with the reactor or with something that could bring to the conclusion that matter can be fission, like the outcomes of Laue-Langevin and Niels Bohr, respectively in 33 and 39. Niels Bohr in 39 first announced in 39. Consider that Einstein, we shall see that in detail, issued his E equal mc squared in 95. Was 1905, and then only after almost 30 years we had to wait up to 42 for the first experiment concluding that matter could be fission, that matter could once fission elaborate and produce energy, and in this way certify, can say, and corroborate the theory of Einstein. You had to wait for 30 years or less until experimental results, of course, based on a machine that was not available in 1905 at the time Einstein elaborated the theory, that could finally bring to the conclusion that it was possible to have a controlled chain reaction, so producing a central of nuclear energy, or an uncontrolled reaction, the atomic bomb. Let's see in detail the time how this works. First, we have direct synthesis. Let's say that a standard capability of synthesis of a human being is not 15, it's 2. It's just 2. I can correlate just 2 information at a time. So I will begin to derive synthesis. Based on derived synthesis, I will have, of course, still other derivation. Again, other derivation that apparently could bring to nothing. Like the famous E equal mc squared of Einstein's majority. Seems something weird, a blurry result came up from theory that does not work. No? Then there are some other data, like of course the discovery of relativity and blender, as we were saying before, that could bring with other information, like the outcomes of 33 and 39, to something that could be related with information derived from the other. So finally, I can have synthesis between new experimental data and other experimental data that produce other synthesis, like of course in the experimental techniques that were developing to study relativity, something absolutely not correlated with the relativity. But they were bringing new synthesis. And then other data, like, you know, the capability to construct a reactor, something where matter could be efficient and controlled in the fission. So that finally, you came to very, very important results for which, like, you know, a new experimental data or other derived information can be related as well with other pairs of information. Such to have, of course, more and more rapidly a fertile synthesis that can bring to something. When you begin to be right at the very end, of course, the process speed up because you finally have the true elements, the consistent elements, the consistent derived elements that can bring you to some results. The construction of an atomic bomb, the construction of a nuclear central. So at this time, rapidly, very rapidly, you can get to the final synthesis, a central or an atomic bomb. But what's so long time, you know, from the first very observation of the unsurmountability of the speed of light up to the first experiment, you know, Trinity, you know, the first atomic bomb before the so horrible outcomes, American outcomes of Hiroshima and Nagasaki. So, seems that nothing, no man on earth, nothing can be derived from scratch. It is so, for example, for special relativity, the work of Einstein, and possibly others, as I was saying before, was based on the space-time transformation of Hendrik Lorentz, the relativistic space-time transformation of Hendrik Lorentz. B is the famous parameter, no? Comparing the two speeds. Speed of the object is c. So it would be 1 if we move on speed of light. The tensor of Hermann-Minkowski, the basic tensor of space-time used in special relativity that, of course, get more complex, we should say, in general relativity. All this information were the playground where Einstein could elaborate this theory. Again, about general relativity. The work of Georg Friedrich Bernhard Riemann, the tensor of Riemann, the tensor that, based on the Christoffel symbols, were producing the curvature of space-time, were finally give a mathematical tool to control, to check, to measure the curvature of space-time. The Grigori-Ricci-Kurbastro tensor, that is a synthesis, you know, you contract two indexes of the Riemann tensor, and you get the Ricci tensor and the Ricci scala, again contracting indexes. So after that, the work should be put in first place because those connection coefficients or Christoffel coefficients from Helvig, Bruno, Christoffel are those entering in the Riemann tensor. So you see, continuously someone is using the work of someone else. No one on the earth starts from scratch and invent the atomic bomb. In particular, what was saying Fermi about all those processes? Fermi was simply said, very nimbly, speed in the lab led me to the Nobel Prize, very honestly. The very discoveries I came to, some would have been made by someone else. I simply got there sooner. It is like that. After that Nobel Prize, it's a prize. It's a competition. You know, I like in Siena says for the podium. The most stupid one is whereas second, because you couldn't have the chance to arrive first, and there is a second place. So it was a certainty in that. It was not because it was Fermi, it was not because Maxwell was Maxwell, it was not because Einstein was Einstein. Someone else instead of them would have get the same very conclusion. Only who got first is the one that get the prize. Follow that. Very simple. So, this is the prologue. Sorry about I looked at a bit too long in that, but anyways, let's focus on the theory. What does the theory proposes to us? First, has Einstein been always right? Wrong. Wrong because he had his good misconclusions, unfortunately. So, a bit of history first. The famous formula, E = mc squared. Do you think this is correct? Think about it. Do you think this is correct? It's worldwide famous, but do you think this is, like this, is fully correct? Wrong! Because this is the way in which you get a formula. After those 2 pages, simply 2 pages of not that complex math, you get this formula in differential form. So what happens? Happens that if you go from the formula getting in differential form, the exact way to express the Einstein equation would be that as an integral between initial and final energy corresponding to initial and final mass related to an initial and final speed. Someone could say, but no, wait. We got this equivalence that is absolutely correct. So that if I said P equal to 0, if I set P equals 0, produce me an mc squared. So what I was expecting. But related with the relation to the very first formula, that would be the conclusion. Would be the conclusion for which I'm referring, writing E = mc squared to the rest mass of the body. So I consider the entire energy of the body from 0 mass up to the actual mass m of u. So pay attention. That is the rest mass of the body. That is the energy that would be derived if I completely fission the body. Those are the conditions which the formula we saw before is true. So, why this is worldwide famous? Because it's beauty, like the Dirac equation, no? So synthetic, so short, so condensed. This is a beauty. It's a beauty. This formula. I saw once a T-shirt, and where by again? In España hace mucho calor. That's beauty, no? So imagine a shirt like that, no? In España hace mucho calor. This note at the bottom. Should the energy be referred to the rest mass of the body? It would be true. So that's why, as well, if you can say incorrect, like the Tumber. Now, as well if incorrect, this formula is worldwide famous. In particular, coming back to the differential form of this formula, what happened? Happened that it was mentioned before that Fermi, playing with his tools, with his graphite, carbon, or was playing with his first reactor, the famous pile 1 of the Chicago lab. And based on the outcomes, as we were mentioning, of 1933 by Laue-Langevin, the concept of a nuclear chain reaction was first hypothesized by the Hungarian scientist Laue-Langevin on September 12, 1933. The outcome of 1939 of Niels Bohr's that an Orion fission could represent a possible source of nuclear power. So Fermi played with these tools, and after that, well, getting his life away because of the radiation in the catch, was really discovering that something was happening, starting from the differential flow. What? Yes. That the ratio between the energy it was obtaining with the reactor and the mass that was fission in the reactor was an incredible, huge number, the square of light. That's it. A little gossip. Einstein, why he was so, doubtful about this theory? He was doubtful because he was convinced that the theory was blurred, was something like that, something very weird. And gossips, let's talk about the gossips. Some more will say that it was not really the other, but why? There is eyewitnesses evidence that several letters over many years indicating that Mileva marriage, the wife of Einstein, might have collaborated with him prior to his landmark 1905 papers, and that they developed some of the concepts together during their studies. So when the theory step by step became more accepted, more credible, after we have to wait to repeat 2 years for the certification on that, Einstein was getting nervous about this possible involvement. So as well, he ran away from home to have an affair with his cousin, and after that he came back with so tough rules for the wife, the famous decalogue. He asked that he demanded that his clothes and underwear are to be kept in good order and condition. That he had to receive 3 regular meals in his room. That his bedroom and study had to be always clean, and in particular that he could be the sole to lay hands on his dashboard. That she didn't, Mileva, have to expect intimacy. That she had to stop talking to him immediately if he asked. That she had to get out of the room instantly without protesting, should have he requested, that's a mistake, should have he requested. So, something like a very tough condition that Mileno stand because of children, because of his love for the man, but after that she couldn't stand anymore. So in 1919 they broke up. So when, let's focus now after this history and gossips. When really Einstein had been really wrong? Talking about the modeling of a static universe. He was convinced that the universe had to be static. Only that, using the Friedman, Lemaitre, Robertson-Walker coordinates that are those introducing a radial variable in the metric. Of course, those are quite complex concept. Anyways, all it's described in the book, and anyways, cannot be all the theory been described in this presentation. So, inserting, using this metric, presenting a radial variable that could be used to reproduce the inflation of the universe, so it's possible deformations. And second variable, an ET, something like that. This one, you can say an epsilon t, an infinitesimal variation in this variable, that variation should contain in time, but it's not. Elaborating, still with a couple of pages, elaborating the theory, you get that this parameter is going to diverge with time. So it's not a parameter that after that cancel off, as should be for an arbitrary parameter. It's something that diverges with time. So it was not possible. Still having a simple, piece of paper in front of us to consider the universe extended. It's something like Amadi was saying that he was talking about the physicist infinitely able that could have deduct at the table, a tavolino, at the table, all starting from the Maxwell equations, all the rules of electromagnetism. In this case, a tavolino at the table, Einstein could have himself deduced that, inferred that the universe could not be static at all. Einstein could have himself demonstrated on a mere mathematical basis, with the sole adoption of the freedom of arguments of working method that was available at this time, at Einstein times, the inconsistency of the introduction of a positive cosmological constant aimed to achieve a static universe. So what happened? Hubble was demonstrating, was observing that the universe was not static. The experimental that the universe was even accelerating expanding. So it was not static at all. But no interference with Hubble, because when you show it to Einstein, you have to recognize that his theory was not correct. But anyway, I repeat, he could have as well by himself understand that. So the universe could not, anyways, be static. Starting from his own equation, the ether, Einstein field equations. Another issue, the Einstein's issue about the one about gravitational waves. So remembering the fact that there was a problem of singularities, then this time you won't frame me, you won't pin me over the first talking about singularities. And then about gravitational waves. In 1936, Albert Einstein and Nathan Rosen submitted the papers to Physical Review in which they claimed gravitational waves do not exist in the full general theory of relativity. So Einstein was not saying that gravitational waves were available, were a possible conclusion of this equation. The contrary, in the first place. He believed that the statements sustaining the Terry correspondence solution of the field equation would have had a singularity. Only that, what happened? That the journal sent their manuscript to be reviewed by Howard Percy and Robertson, who anonymously reported that the divergence in question were simply due to harmless coordinate singularities of the adopted cylindrical system of reference. Einstein, who was unfamiliar with peer reviews, angry with the manuscript, swearing to never publish again in that journal. Only that, nonetheless, what happened? That Einstein assistant Leopold Infeld, while being in contact with Robertson, convinced him, Einstein, that the criticism was correct indeed. The paper was then rewritten providing opposite. So, think about in this case the opportunism, providing opposite conclusion and publish elsewhere. So, then the very important can say issue, the Newtonian limit. What happened? Again, simply page calculation in what is referred as the linearized field equation, in which you use this approach with a linear term that corrects the space-time metric. And it is linear because you consider to have weak fields in coming into play. So if you consider the time-time the time-time term of the linearized field equation, and then you plug in, that is an identification. The three lines are for identification. You identify, you plug in, you identify it with a gravitational potential. It's clear that you get something sounding like Newtonian in relativity. But it's just a pure identification that you make. Again, you can go to the metric, the time term of the metric, and then have the gravitational potential. Okay, it's still a fruit of this mere alleged identification. So, essentially, physics is made of formulas written on a piece of paper. And those do exactly what the physicist wants them to do. That is to say, if you want to obtain a result, you write formulas, you prepare your theory to get the result. The problem is that the result must be true, so must be verifiable, must be false or true, again, as Karl Popper were sustaining. In the sense that you have to produce some evidences that corroborate your model, that corroborate your theory. So, after that, the incredible outcome of Einstein. General relativity encompasses the conclusions, based on an alleged identification, encompasses the Newtonian mechanics in such a way to render as the Newton law of gravitation, of course you get the Newton law of gravitation, it's reasonable. General relativity is based on space-time deformation due to a gravitational field. So of course it comes into play the force of gravity. So the Newtonian law of gravitation. Okay. In the limit of weak gravitational fields. This is good. Again, gravity should no longer be regarded as a force in the conventional sense of Newtonian dynamics, but rather as a manifestation of the curvature or the curvature of space-time. This curvature being induced by the presence of matter. Of course, this curvature is induced by the presence of matter. Okay, this is correct. But it's not that you have to identify gravity. You have not anymore to identify gravity with Newtonian dynamics, but with general relativity's difference. And then the final sentence. Gravity arises because the effect of the presence of matter in the universe is to distort the flat Minkowski space-time. This is correct. But yet, the distortions manifest themselves as we view as the force of gravity, and that these same distortions must render in the limit of weak gravity, as we were saying before, as the familiar Newtonian theory. So, the very conclusion is gravity is purely geometrical. Whoa, Mr. Einstein, how pretentious you are. It is not. It's much more simple. It's much more humble. Let me say humble. How general relativity works. This is a map. You start from a metric. Then you plug this metric in the connection coefficients, the Christoffel coefficients we saw before, and you check those within the Einstein equation. The Einstein equation in presence of matter, or more reasonably the Einstein equation in vacuum. So G mu no equal to 0. If this equation is satisfied, you go ahead. If not, simply the metric is not a suitable metric. It says the metric is whichever metric you can construct as infinite to hand matrix, but it's not suitable for the Einstein equation. If yes, you plug the metric, you plug the connection coefficients in the geodesic equation, and using Newtonian mechanics, which elaborates the word line, you feed the geodesic equation where the connection coefficients are present, you feed this equation with the word line. The result is the relativistic correction. So it's not a new mechanics. It's not something that reproduces the mechanics. The Kepler, say for the cosmological point of view, the Kepler's equations. No, Kepler's equations come from Newtonian mechanics. What gives to you as added value general relativity is the relativistic correction to the motion. More than that, what you do in general is that with the metric you feed the Newtonian mechanics, you plug the metric in the Newtonian mechanics to the Newtonian, you let work the Newtonian mechanics not work anymore on a flat space but on a curved space, and then the Newtonian mechanics itself, as we shall see in short, will produce the relativistic correction. So as simple as that. It's the same element feed with a space curve that produce the relativistic correction. So the extra terms that you're expecting to give you what the famous added value, the corrections that you're expecting from general relativity. More in detail, the same very equations is the Newtonian mechanics Laue-Lagrange equation. There is always this, always. If you feed this equation with a relativistic Lagrange that is based on the connection coefficients, the Christoffel coefficients, derived from a curved metric that you set, then you got the relativistic equations of motion. There are those. Similarly, Newtonian mechanics, if you start from the very same equation, but you plug in the classical Lagrangian, you got what? The Kepler's equation of motion. So, it's the same inducing principle, the Laue-Lagrange equation, that provides you, in two different cases, equations of motion that are the classical Newtonian one, Kepler's one, or the relativistic ones. In particular, if we consider the relativistic equation of motion, we set in the plane for, consider orbital motion of planets, and so you don't see anymore the elevation variable, the theta variable, just see the two variables, u, that is actually the inverse on the radial variable, and phi, the azimuth variable. Well, compare this equation with the Kepler's equation of motion. What you get, the same term can say a lowest order equation, lowest order terms in the equation, and a correction term, depending on, you see the square of u, then of course is going to 0 and infinity, so at infinity this term vanishes, because you have not any more relevant, consistent relativistic effect. This next to leading order term, that is the relativistic correction. It's all that, not more than that. What you see in general is this photo, and this beauty again. It's something representing space-time deformation. No, this is not true. It's not correct. It's not that the mass goes as weight on the space-time, this sort of frame. See, space-time. For the first time, you see space-time represented not as it's a really vacuum structure, but as a frame. Yeah, this frame is deformed by this mass, but it's not like that. If I use a mass, if I consider a mass and I cross it with a plane, the very deformation is as well inside the mass, as well higher, no? Because as I go to a towards a stronger gravitational field, I have an even stronger deformation of space-time. So this happens everywhere. It's not like something external to a mass. It's something internal to a mass. So starting from the very concept of frame or Adler-like model or something or whichever, we should see possibly a mixture of dark and energy and matter. No? If you really consider this, you could consider that everyday life, it's something that is based on this frame. This frame is not only something acting to a macroscopic level, to a cosmological level. It's something that you could, of course, as a simple logical conclusion, imagine to enter in your life, to enter in your everyday life. So, why not to think as well in the microcosm as an interaction of matter with this frame? Or better, since Adler has been refused, let's think differently. Let's think that matter is made of this something, is made of this frame, is made of this Adler-like Adler-like structure, can say, filling the universe, filling our life, filling our world. So, in this way, the concept of wave particles of duality is immediate because you cannot think to balls, rotating, Imagine now that the universe concentrating in one single point could destroy itself in a second. So there are not balls rotating, but they are resonance of matter, resonance of another like frame, can say, where the particle, in this case, this is a nucleus, and this is not the electron, that is infinitesimally smaller than the nucleus, but is the effect of the field due to electron, the interaction of the electron itself with matter. That could be the representation, for example, of an hydrogen atom, a nucleus composed by a proton and an electron. The interaction, this is a representation, I would say, of a field, in this case the electromagnetic, the electromagnetic field, the electrostatic field, producing the interaction, the attraction between electron and nucleus, with this matter. So in this sense, you have to think differently. We are not, something external to another light system. We are part. We are the result of, let me say, against like Greta Thunberg does, the result of an interaction, the result of a resonance with this frame. If you think to a wave, the concept is immediate in your mind. Why? Because you can see the frame, you can see, you can touch it, you can smell it, you can drink the frame. It's the water. So which is a wave? A wave is not something that you can, it's something that you can see, it's something that you can feel on your body, the pressure of a wave. But it's not something external to water. It's the representation of the interaction of some energy, the energy of pulling along the wave, with water. In the sense, the concept is immediate because you have in front of your eyes the idea of this concept. But this, just if you resurrect the idea of a matter-like frame working for a cosmology in our day life, you will get something more clear in the vision of what could be possibly the reality. And then finally, a possible way, a possible medium where forces can interact. In this case, as we want to show, to demonstrate, to propose at least, electromagnetic and gravitational forces. Practically, all this reasoning is something that has more physical sense in general than think about balls. Think about the interaction of two relative beam size, the representation of two relative beam size about the interaction point at the atom experiment at CERN. You see how this is much more resembling a resonance. Two particles of beam 1 and beam 2 interact to annihilate in a point just, possible negative interference between the two resonances. No, in this case, the two resonances represent these two particles. After that, after interacting, leaving again as two other particles of the very same particles, so particles with different names, different mass, of the very same particles. But this is something more resembling what I've just theorized, you can say. Something much more physically evident than the stereo diagram of the Moore scattering or the Baba scattering. Those diagrams, those Feynman diagrams are extremely efficient, extremely handy on the very math point of view, on the very theoretical point of view, to represent an interaction. But of course, they are stereo with respect to the physical reality of things. In general, I repeat, that could lead our real life, our very life, because if you start from the elementary particle, like a quark, then you get a proton, the structure of an hadron. Then you go to a nucleus. Then you go to an atom, to a molecule, to a cell composing our very body, increasing from 10 to minus 17 to up to 10 to minus 5 and to our standard dimensions. So all our life is based on the, could we infer that all our life is based on this interaction? In the sense that we are as well fruit of this resonance. When we move, we could imagine that we cease to exist in a point of space-time to exist in a point, to reconstruct ourselves in a point infinitesimally close. Exactly as a wave does, with this energy that flows through the sea and represent the wave of moving. The same could be our body, a sort of flow of energy, a flow of our energy. Our rest mass energy, flowing through this medium. Well, words, and again, words. All those words could find a representation, could find, a collaboration in experimental evidences. First, the relativistic corrections. Talking about perihelion precession, we have that in case of Mercury, in this case. You start from the relativistic equation of motion, again with this correct term. You use this correcting variable where you set a parameter, an arbitrary parameter, eta, close to 1, representing the correction of the angle, the azimuth angle phi. Of course, this parameter cancels off because it's an arbitrary one, of course, and gives this very result, that is the relativistic correction for the perihelion. Of course, here you get immediately a limit of the model. If A goes to 1, you have an infinite correction, you can say, a divergent correction. But if E goes to 0, like for a perfect round orbit, imagine, still you get a correction, whereas the physical reality tells you that that's not to happen, as we shall see in short. Anyways, the relativistic precession per orbit, calculated for Mercury in this case, is very dirty figures. And nonetheless, integrated of an orbital period of 88 days, corresponding to 415 revolutions revolution per century over the century, provides you this quite consistent number, 42.94, almost 43 seconds per degree. So, as we were saying, the orbiting plane moves in zones, perihelion and aphelion, where space-time curvature, what happens physically, where space-time curvature is maximally different. In other words, what brings asymmetries in the space-time curvature the orbiting plane moves through is the responsible of the relativistic precession. So again, since the total precession of Mercury is estimated in 474 seconds per degree, you have that per century, you have that the principal cause being the principal cause of the Newtonian perturbation due to the surrounding planets. You get the correction. Remember, first we talked about correction. That you get a big correction due to general relativity. Is then about an order of magnitude lower. 43 bar against 474. But it can be clearly observed because of the cumulative nature of the process, the integration of time in the process. Something very simple to represent the cumulative nature of some phenomenon. You can simply think to the pendulum or the wall clock of your house. As you move the screw of the pendulum, you get an infinitesimal variation, hundreds of seconds, thousands of seconds, a second in the period of the clock. So something that you cannot appreciate. But if you integrate over, I can say, an hour, 1 day, a week, those oscillations, you get an effect that you can appreciate about how the measure of time change moving, trimming the screw. So if now the clock is fast, slow, or finally right, telling you the time. Space-time effects. You get a gravitational redshift. A light beam has been shed, moving out from a mass, undergoes a gravitational redshift. Again, you use the time term provided by, in this case, the Schwarzschild metric, contraposed to Kerr metric, that is the most used metrics for non-rotating static or rotating, so stationary bodies. And you get this result for the frequency shift that produce a very good identifier again, 10 to minus 6, but still appreciable. Also, what happens? That redshifting is reduced when a light beam enters the gravitational field, because counter-redshifted, because you enter a gravitational field, one year, to measure the light beam, to measure the frequency of the light beam. So more refined calculation would provide a value smaller by factor 1.05. So a bit smaller, but again, appreciable. And then, with the use of radar coming after 50s, 60s, with strong power and emission, you get that going to the superior connection, for example, Venus with the Sun, you get a delay in the relativistic, you get a relativistic delay in the echo of the radar, for the fact that the radar is not, the radar path is not straight, but goes to a relativistic path that is curved because of the curvature set by the Sun. It's not a straight one, not a straight one, but it goes, you point a bit off of the Sun, and then you still at Venus because of the relativistic correction to the curvature of the path. So clearly, this path being not straight but curved sets a delay in the time of in the echo time that would be not expected if going straight. So again, using the relativistic equation of motion, you get the delay time, that is this number, that produce, for the case of Venus, the superior connection, this appreciable result. A delay difference of time, a relativistic correction, again, of about 252 microseconds. This has been perfectly checked by the haystack and the receiver haystack belonging to the Massachusetts Institute of Technology and the receiver observatory in Puerto Rico. This has been perfectly checked in the superior conjunction, for example, since 1970, 25 of January, of the Earth-Venus pendulum observation in the superior conjunction of Venus and Earth. Of course, superior conjunction, because if the planet would be here, you should not check, you should not measure any relativistic correction. The planet must be in superior connection, so you cross the sun and you get a relativistic correction due to the curvature of space-time, due to the star. But which is let's use a word about this. Which is this weird correlation about, apparently weird correlation about space and time? Why? Now, time comes to be correlated with space. Think about it. Is time a physical variable? Think about it. Wrong. No. It is not a physical variable. What is time? Time is a counter. Ct coming into the transformation with the space variable, you have Ct, not T, Ct, that is a physical variable. Because you get speed, that is a physical variable, times a counter, that is the time. So, which is time? Which is time? Which is a counter? The counter is the counter of the pendulum your wall clock at home. Is the counter due to the resonance of quartz, of a resonant chamber made of quartz. So, more in detail, how we define a second? Let's think about it. The second is the duration of 9,192,632,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the cesium 133 atom. So here is the perfect representation of which is time, not a physical variable, a counter. So what happens when occurs this so weird thing for which space contract and time dilates? Think very naively, but that can produce an immediate view of the problem. Think to a man. Don't think to a person. He's a man, could be a woman. Smashing a ball towards the ground. Closing, stopping a ball towards the ground. Thinking in just one dimension, you can imagine that closing the ball towards the ground is reducing the space available for the ball, is contracting the space available for the ball. So what happens? That the ball, moving in a shorter space, begins to go up and down with an higher frequency. So imagine that the ball is a counter. This counter will begin to count more rapidly. So if you would measure the time produced by a counter counting more fast, you would get a longer time. You would count more periods, so you would have a longer time measure. So the time would be dilated. So this is a very naive but immediate view representing how contracting spaces, time delays, and vice versa. Again, something going to corroborate this time. Let's go back to our space-time, huh? to our Adelaide frame. About frame dragging, what you have several probes for the Schwarzschild metric and the Kerr metric. You have probes in which an object is sent flying around the Earth, a clock is sent flying around the Earth with plus or minus speed. So, clockwise or counterclockwise with respect to the Earth. Again, you use the Schwarzschild metric to represent the element or length in the metric, the Schwarzschild metric, to represent the metric. From this, d tau is the proper time of the clock, forbidden. From this, setting d phi equal, so the azimuth variable, you're still in the plane, working in the plane, huh? Setting the azimuth variable equal to the angular speed of the Earth by the time. So in this way you can somehow make the metric rotating. You get that moving eastward and westward, you get two different times measured. Of course, as you set omega to 0, you get the same value. You get no more difference between them. So this is an evidence that something is due to the frame dragging of this, you can say either like medium or simply a frame that is dragged along by the Earth. The results, after an experimental check of this scenario, are evident and are 59 moving eastward and 9 nanoseconds, and minus, because you get the opposite effect, 275 nanoseconds moving westward. So you have a very tangible, a very tangible effect. If you move eastward, that is, contrary to the Earth motion, you have a smaller effect that as you move with the Earth motion. So, following the dragging of the frame, or going against the dragging of the frame. We shall see better this in short. With the Kerr metric, it is considering a rotating metric as the Kerr one, contrary to the Schwarzschild one. This is what has been proved by the gravity probe C. More or less the same experience, producing for the Kerr metric this difference between the two times, moving eastward and westward. So, with respect to the Schwarzschild, what you get? For a period of time, for an entire period of time due to Earth rotation, so after complete rotation of the Earth, you get for a single rotation, you get this result for the Schwarzschild metric. This result that is more or less this one, 16 up to 5, for the decision that should be 16 up to 4. So why? Because we made the Schwarzschild metric rotating. Schwarzschild or Schwarzschild. Metric rotating. By what? By the famous term d phi equal to omega dt that we said before. So again, if you make it, you do, math, do what the physicist wants it to do. If you want the metric to rotate, the metric rotates, and so you get the same result. setting this variable, rotating, or starting from a rotating metric like the curve 1. The very same results. And all is due to this frame dragging of the Earth. This is a representation of that. You see, finally, this, you can say, error-like medium that is dragged along. This frame, or whichever you want to call it, that is dragged along by the rotation of a massive body. So this has been checked as well by the third probe, that is nonetheless the B probe, that checked the frame dragging. So with this set, the gravity probe B, this experimental setup, Saturn has been accumulated in polar orbit at 642 kilometers of altitude, making use of 4 London moment gyroscope. Those work in conjunction with the telescope aiming at the reference, or guidance star HR 8703, that is a binary star in the Pegasus constellation. So what you get? You get two effects. One is the geodetic effect, that is the standard mechanical, well, the effect due to classical mechanics. You have a gyroscope rotating around a body. So since this gyroscope is not uniform, has a definite mass, land has definite dimension, we'll have orbiting around a part that will have an higher angular momentum, a part that will have a lower angular momentum. Mixing together those two parts orbiting around the Earth, of course, you have a mixing that brings the deviation on the axis aiming to the guiding star that is purely mechanical, the geodetical effect. But you have as well the lens steering effect, that has been named because of the experimenter that proposed this, and then this experiment, sorry. Lens and theory. You have the lens and theory effect that brings along a deviation in the orthogonal direction, because this is the deviation due to the fact that you are moving where the Earth drags the frame in which you are moving. So this frame has a mechanical effect on the gyroscope. Moving is axis of rotation, offsetting is axis of rotation. In particular, you expect a geodetic effect due to about 6.6 arcsecond per year, and you speak theoretically, and you expect the lens steering effect deviation corresponding to 49.30, almost 50 milliardsecond per year, so extremely reduced, a smaller effect than the geodetic one, but still a pressure. The theoretical prediction is a little bit higher with respect to the experimental results, but I mean, still you have a real proof that something is dragging a medium outside the body. Something is dragging another like medium or a frame. Call it, it's not a problem, it's a problem which is physical. Which is physically, I mean, possible or not to conceive this medium, since you have those experimental results of a defined and very, I mean, clear dragging of it. As well, other hypothesis goes to gravitomagnetism. So they imagine that the very gravitational field of the Earth can be identified with a magnetic field. So in practical, identifying again purely allegedly, electric potential and electrostatic potential and magnetic potential with gravitational potential and this hypothetical magnetic potential due to gravity, you have this possible identification that still is purely theoretical, it's a model, it's a speculation. It's a speculation of your mind. In what could this reflect actually? In what has been observed as astrophysical jet. Astrophysical jet coming out from a black hole. This is the accretion disk of a black hole. The black hole emits those astrophysical jets that are jets made by gamma rays. So they imagine that the magnetic field, due to the gravitational field of the Earth, interacts with the spin of the gamma rays, oriented those in this kind of spiral, this astrophysical jet. But, I mean, why do not simply think to a possible, for the first time, we see this, why do not think to a possible interaction between electromagnetic and gravitational forces? In the sense that it is not because of possible alleged identification of gravitational field with gravitation, with a possible equivalent magnetic field. Think simply about that. This GAN frame drags because of an interaction with electromagnetic forces, with electromagnetic field due to the photon emitted from the black hole, interacts and drives it. So again, very naively, repeat, just take this as a naval interpretation, just to give you a very direct, immediately representation of what I'm saying. Think about a car, not touching the ground, with wheels revolving. You cannot see anything. You cannot see any dynamic effect. But as the car touches the ground, the spinning of the wheels renders as dynamics of the car. So again, if a possible mechanical interaction to this medium, this other-like medium, could occur between electromagnetic and gravitational forces, this interaction could be the one giving a reason to astrophysical jets. Again, possible interpretation. But let's go forward with the propagation of gravitational waves. Another way in which you can see a mechanical effect between masses and frames. In particular, to get the gravitational waves, to model gravitational waves, you start from a gravity over frame interaction of a binary. So you consider a binary, and you consider one part of the binary interacting with the other. So the space-time deformation due to a binary interacting with the space-time deformation due to the other. This mutual interaction, as you could say, not as a particle, charged particles moving in vacuum, but this charged particles moving, and you get the lens force, the lens equation that produce to you the force that gives you the force when a charged particle moves into a gravitational field. So it's the interaction of something charged with something magnetic producing this force. But in this case, it's the mutual action of a mass moving in the other frame or the other, producing the effect. Actually, modeling the energy momentum tensor of the self-gravitation field with a massive body, you get this term that has a quite complex expression, fully described in the book, that reduced to this much more simple expression in which you get the tensor of radiation or the of the gravitational wave. This is the geometry representation of the phenomenon, and this is to represent what? That you are still to work, because the presence of the H, the linearized field equation tensor in the equation, that you still the weak field approach. That is to say, why you cannot check gravitational waves on the Earth, considering the binary system corresponding to the Sun-Earth system or Earth-Moon system? Because this is not a binary. First, for two reasons. First reason that this is not a binary, because the Sun is extremely more massive than Earth. So the center of mass is very close to the Sun, practically is the Earth moving around the Sun. The same happens for Earth and Moon. The Earth is much more massive than the Moon. So you cannot consider this as a binary. And also, what happens? That you have in your very gravitational field, the one due to Earth. So practically, you are not in this condition. You have practically, you should have, in case, an extremely small effect, the gravitational wave emitted because of the rotation of this, let's say, potential binary. It's not a binary, because I repeat, the barycenter has been in between the two masses, the center of mass of the system must be almost in between the two masses. But the fact that your physical data would be, submerged in a so noisy environment due to the gravitational field. That is not the case when you are in a point and you check gravitational wave emitted by a binary that is distant, thousands of light years from your receiver. In case of gravitational waves, interferometric system, optical interferometric system, or resonance cylinder, or similar. So, other proof, other possible evidences, other possible clues. The cosmic microwave background and Big Bang model. You have that at the beginning of the life of the universe. You had an extremely fast expansion of the space-time. So the concept is that was not matter that expanded. Matter was not a system. First, space-time expanded for what we have modelized after the discovery of the cosmic microwave background. First, space-time expanded, then matter expanded. That is something that matches with our present universe, the accelerated expansion of the universe, and the background, the distribution of the microwave background. So what happened is that, as for the Big Bang model, in the first 10 to minus 32 seconds of life of the Big Bang, what has been named inflationary epoch, the universe suddenly expanded and its volume increased by a factor of about 10 to 78, corresponding to 10 to 26 in each of the three dimensions. So, an extremely huge speed, about 3.3, 10 to 40 times the speed of light. So, what brings you to think this? That vacuum is not that vacuum, cannot be that vacuum, because when vacuum was really vacui, at the beginning of the universe, the space-time expanded at an extremely higher speed, because there was not matter. Vacuum was already matter. Was already vacuum. There was not only planets and stars. There was not this kind of what we say frame or ether-like medium that is now filling the universe. That is the responsible the dynamics of the universe is flowing on. So at the time of vacuum vacui, the universe could expand with that speed because the vacuum was really empty, So again, something that could, not proof, but still sustain a possible model in which this ether-like medium has to be resurrected, has to be considered. Then, final, can say, observation about the ultimate fate still. Purely speculated theory, the ultimate fate of the universe. So what we see, modelizing the universe as for the Friedmann-Lemaitre equations, what we see that moving from the S-time de Sitter up to the de Sitter point, the universe is following one of those paths, one of those possible paths. So what you get, that the density of mass is going to zero to become full density of matter, of vacuum. The density of vacuum is to consider this lambda variable. It is the famous lambda variable for the introduced as well in the first time, before Einstein said, and it was my biggest bullet, it was my the insertion of the cosmological constant was my biggest blunder. In reality, the cosmological constant had not to be used as Einstein said, after that contradicted by Hubble, but is used to modelize the expansion of the universe and the vacuum, in particular, in this model, the vacuum density of energy. That could be this time, let's name them, dark energy or dark mass. But it is the form of vacuum energy in which the universe is resolving. So what we think that as well now, where the universe is that in which we are living, there is a transformation. Following this model, there is a transformation of matter into vacuum, into some kind of part, can say, structure or whichever, that is nothing more visible, that is nothing more tangible. It's vacuum. But still, which is the very border between matter and vacuum? So as we can see that vacuum at this point is really vacuum, or is simply filled up by something, can say something that we cannot see, that we cannot touch, that we cannot measure, that we cannot reveal, but that exists and is sometimes influencing other experimental results as well. If you cannot, check it out by its own. In particular, in detail, the universe will undergo a total transformation into density of vacuum. That is, the universe appears to be bound to spread it to infinity without any remnant of visible matter in it. Or visible matter will morph into dark components. That is, this further sustains conjecturing vacuum as not a mere void for space. So, again, the resurrection of the early light medium. It must be rather thought as filled by a medium, possibly dark matter and or dark energy, that definitely demands to resurrect another light model into which construe the full fundamental forces on nature. So this is as well what experimental data provides to us. So now, bending electromagnetic beams. Here is a case in which we flashback. So the very early proof of general relativity, or special relativity, or better, general relativity, because it's not in one dimension, it's three dimensions, so general relativity. So the consolidated verification of the theory, the general one, is the one for which Einstein had to wait until the observation made in occasion the total solar eclipse of May 29, 1919, the occasion in which Einstein obtained, as well if the results were not that so alone, the theory was anyway correct. So he was expecting that anyways the theory had to be correct. And it was. So it was revealed by Eddington that light bending was a physical reality. Observations were carried on by two expeditions, one to the West African island of Principe, led by Eddington, and Edwin Turner Cottingham from Cambridge Observatory. The other to the Brazilian town of Sobral, led by Andrew Crommelin and Charles Randall Davidson from the Greenwich Observatory in London. What they observed is that a photon approaching with an impact parameter called B, approaching a massive body, turns and is deviated by an angle d phi. So again, starting from the relativistic equation of motion, in this case, that is different from what we saw before because it's the one value for fluids. So for massless particles, we have here our correcting term going as u to third power. We got this correction. This correction is producing as well quite identical result, theoretical results, or 1.75 seconds of degree, but observable. In this case, optics can help us a lot. Practically, what has been checked during data extracted in 1919, 22, 29, 26, 47, 52, or the several eclipses in which light rays were created in the sun, those are the deviations revealed. You see? What you see? Well, you see that all are higher than 1.75 seconds of degree. But more. It is the very clue leading to our experiment. After using techniques of radar techniques of detection of microwave radio signals, checking as well at the eclipse the signal sent, the microwave signal sent by the 3C279 quasar, they reveal those kind of deviation. Let's check it out. Still higher than the theoretical prediction, but relativistic and statistically smaller than the one due to Langevin. So those data are available since the 70s, more or less. So which is the very point? Is that seems that more than the theoretical deviation due to a relativistic correction, we have to expect something. Not a next to leading order, a next to next, we shall see this in detail, a next to next to leading order term that brings a further deviation that deviates even more light beams than radio signals with respect to the standard deviation expected from general relativity. So what happens is that if this is the observed time, because the actual time is here, but the curved part, let's see, let's figure your observed time at a different point. What happens between sources and star, so between microwave signals and gamma ray beams, is that the observed star source corresponds to a different deviation. Here is extremely exaggerated, but still an experimental appreciable difference deviation between star, so gamma rays, and source. So finally, going to the experiment, what we need, what is the concept, the idea that has to draw us. What we need are a tunable gamma ray source. As we can know the energy of a gamma ray source, and we can tune this energy, we can see tuning this energy if there is any deviation, like in this gamma ray source, this gamma ray beam crossing an opportune gravitational field. So we have a gamma ray beam due to a tunable source. We have a gravitational field. We have an interaction. We can hypothesize an interaction between the two and see if tuning the gamma ray source, the energy of the gamma ray source, we can as well reveal some deviation in the direction of the beam. So where we can start from? We can start from the gamma decay, so the production of two gamma rays. The gamma decay that is checked at LHC, Large Hadron Collider, or CERN. The possible representation diagram, the Feynman diagram representation of the interaction is this, where two hadrons are let collide at high energy to produce such to produce a Higgs boson via gluon fusion by quark loop. Gluon fusion, quark loop, produce an Higgs, and the Higgs with extremely short lifetime produced by the quark loop decays via an intermediate weak boson, the W plus or minus boson, which again by a loop decays into paraphotons, so gamma rays, whose energy will be piloted by the Higgs, the intermediate boson, resonance. So practically, what I expect is this. From the Higgs to gamma gamma 2 and to the gamma decay, is expect a variation of almost 100 kiloelectron volt from 30 to 130 kiloelectron volt for a difference in the energy of the resonating Higgs in the central parts and the most reliable resonating part from 170, but actually from you can expect this variation from 150 to 460 gigaelectron volt. Of course, here you could explore as well. Higher power, higher big difference, but that should be out of the spectral resonance of the Higgs. But again, the experience could drive you to check what happened with this big variation, increasing the resonant energy of the Higgs. So quite a space for experimental checks. And considering just the Higgs resonance, so you have a gamma radiation and in an Higgs energy interval about 170 and 460 gigaelectron volt. The radiation channel corresponds to tunable source of gamma rays whose energy can be measured with high precision. With high precision, not with high precision. So Higgs decay, we have to say that Higgs decay into photon is very rare, happening only twice every 1,000 decays. Nevertheless, this process has been of quite relevance during the experimental search of the Higgs, since energy and momentum of photons can be measured, as we were saying, with very high accuracy. So practically, the cross-section of the processes, this one simplified because of this very last process that has a very cross-section, a reduced cross-section, quite a simple one that produce, moving from units, provides this quite daunting result, a cross-section of very reduced value, about 10 to minus 37, so very reduced cross-section, but still, available. That is very important, and tunable. That is very important. So the general experiment concept, expect this. I get an approaching photon, a depleted uranium bomb that is the one creating our field, and an equivalent representation in which the entire bond is represented as a point. So we go to the modelizing of the gamma ray beams deflection and gamma ray beam deflection that we saw before in the Electron experience. You can see in which an approaching photon approaching this mass is deviated by a different angle. That could be the representation of the scenario. The interaction point, the gamma ray, the rotating depleted uranium bomb hitting a target screen where I detect and reveal those gamma rays. Practically, an equivalent representation would be that depleted uranium bar, shafts making the bar rotating, and gamma rays crossing, hitting the target screen. Depleted uranium is one of the denser material. Why depleted uranium? Because it's the one of the denser material nowadays available, with a density of 19.1 grams for cube centimeter, about 68.4% denser than the image. So a possible location would be the LSCB experiment at CERN, in which we have this scenario, the experiment LSCB, and a point depicted as future experiment, represented as future experiment, along the ring. Practically, along the ring, the LSC ring, we have an RF future experiments point available for new activity, new setups, and the LACB experiment, which is the existing one. The idea is then use these facilities with employing a ring of 27 kilometer girth, corresponding to 8.594 kilometers diameter, having two nodes set diametrically opposite. Already, they are perfectly diametrically opposite. Imagine what we refer to. It has a location supposed to be a future installation. The other one is the location of the present LHCb experiment. So issues and innovations. The deviation angle we expect, assuming 50 centimeters as impact parameter, so about, we gain in this case, about 9 orders of magnitude lower than solar radius. And imagine a view bar of 35 centimeter long, 5 centimeters thick, and about 8.5 kilometer long for a total mass, depleted uranium, for a total mass of 2.841, 10 to 6 million kilograms, would be, unfortunately, 24 orders of magnitude lower than the solar mass. So the result is that the radiation would be miserable, 10 to minus 15 Earth seconds, corresponding to a deviation after the entire path followed by the beam, a radial deviation of about 10 to minus 4 picometers. So 10 to 1000 picometer, 10 to minus 4 picometer, that is 10 to minus 12 meters. And extremely dirty results, I repeat. Gamma rays are also hard to diffract, and new techniques of focusing and magnifying are needed. The most promising scientific discovery comes from scientists working at the Ludwig-Maximillians-Univeristät in Munich and the Max Planck Institute of Quantum Optics in Garching. Those are the possibility. Actually, the innovation are in this field, in the gamma ray optics proposed by those groups and lensing application. In particular, experiments at the Institute Laue-Langevin in Grenoble has proven gamma rays to be focused by gold lenses like light beams in the visible spectrum. Laue-Langevin. Laue-Langevin could be something like that. Sorry for the mispronunciation in case. So probably those gold lenses, this is more or less a centimeter of diameter, could focus and could diffract light rays as in the visible spectrum due by standard lenses. Also, the possibility to construct telescopes employing techniques of nested paraboloids and hyperboloids already used for the 6O Chandra X-ray observatory available. The refraction power of gold may be also employed in electing focusing structures, so inside those structures currently used for X-rays, as for the 6XO observatory, Chandra X-ray observatory, to focus and magnify gamma rays. Particularly the hardware we expect to use is this. So from the new interaction point and RF and new experiments points on the LHC ring, respect to collect gamma rays, to let them interact in a block of 1,000 sections of depleted uranium, that is the GEM, Gravitational Electro-Magnetic Interaction section. Those sections are can say, framed by the solution, by a possible solution of continuity represented by 9 in the tail on the tail end of the interaction section of vacuum chamber, producing vacuum in the windpipe of interaction. After that, the magnifying section to get at least a 10 to 4 magnifying ratio, and so go from 10 to minus 4 picometers to picometer. And then on picometer, employ a double detector composed by glass tracker and a stem detector to reveal finally the picometer deviations, and then bring them via the LACB RAM up to the ground, where a track processing system control unit room will be available to guest a redundant processor or sent by a dual equipment line. Those processors will interface then with the monitor and control suite represented by an operative suite and a system control suite, and 2 I/O consoles for software checking of the processor in redundant configuration. In practically different sections, the collimator will employ AC beam pipe parts to replicate and represent interaction point at the which has been called RF and future experiment location on the LSC ring. Those will terminate into an interaction volume, possibly a sphere, which will filter and release gamma rays to the collimator. Then, a water collimator based on water telescope technology developed for the Chandra Observatory, CXO, will channelize the gamma rays coming from the 5.8 diameter source to the focal point, located at about 8 to 10 meters from the interaction point. A convergent lens with focal distance at the focal point will then gather gamma rays to refer back into the collimated and coiled beam. This is what is represented here. Interaction points, nested paraboloids and hyperboloids, focusing ray to a focal point. Then the bank of 50 lenses. This is quite a technicality described in the book, but we use a bank of lenses because a single lens cannot work. So we have to use, based on the principle of the adjacent lens, of the multiple lens, set a bank of 50 lenses that will finally focus those rays and collimate them in a coherent and parallel beam sent to the diaphragm that will dose the energy, the gamma ray energy sent into the GEM interaction section. This is the geometry of this part, as I was saying before, interaction point, nested paraboloids and hyperboloids, focal point, a lens representing, modeling the bank of 50 lenses over there, setting in a coherent beam the gamma rays to the diaphragm. The GEM interaction section, this is what we were saying before, the depleted uranium bar and the shafts. This is the representation of the axial representation of the GEM interaction section. So 10 shafts are accommodated on each flange. We have 2 flanges, an external and internal flange. The separation between each pair of shafts is 36 arc deck, because the 10 shafts correspond to a segment of about 31.4 centimeters. This will allow some mechanical capability to, properly drive between each various shafts in this movement. Then the depleted uranium bomb. So there are sort of technicality fully detailed in the book. But which is the point? Is that if we expect some kind of deflection of the gamma ray hitting the screen, rotating the flange will have this deviation spread on 36t degrees. So we can, paid by the mechanical difficulty to let this bar rotating, we have this effect expanded to 36 degrees. So we can check it much more probably. In practical, I mean, what we have to expect with respect to our neutral result is that it's something that happened, I mean, probing for the gravitational redshift, what has been experimented by Pond and Rebka. They were just using gamma photons produced by iron 57 source, dropping or launching those gamma rays toward a iron 57 detector. They were expecting to see some kind of gravitational shift. Only what happened? What happened that in the experiment, gamma rays emitted by a 0.1 microsecond atomic transition of iron 57 at very reduced energy, 14.4 kiloelectron-volt, were falling from this distance on the resonant receiver, represented by, again, a target of the same material, iron 57. So what happened? That the results, the expected shift for this, extremely low, minus 10 to minus 15. With respect to the figure, the shift, I mean, with respect to the bandwidth of transition corresponding to an error of this, minus 10 to minus 12. So 3 times lower than the error due to the bandwidth, to the bandwidth of the transition. So it was something that was not checkable numerically, right? In terms of a physical, identifiable numerical result, detectable result. So what happened? That they use a loudspeaker to mechanically, by a Doppler effect, introduce another shift. So the Doppler redshift in this case, due to the movement of the loudspeaker, of course, the loudspeaker that produce blue shift and the red shift moving periodically, but the red shift of the loudspeaker would have down the gravitational blue shift, so that periodically, for some interval of time, the loudspeaker cone motion would have totally ruled off any scintillation counting. So, counting the scintillation due to the radiation that were not absorbed because of the blue shifting out of the frequency of absorption, the range of absorption of the frequency of the gamma rays emitted, the scintillation counting were anyways to modify this counting. So they were not able to quote the counting, the difference in counting of the scintillation counter. But they were just simply expecting the scintillation counter to do something different, to reveal something different. They would anyways represent the result of the experiment as well. They were not able to quantify how the scintillation counting should have been changed using the loudspeaker Doppler effect. Practically, the other Doppler effect did not resolve the problem of a lack of sensitivity of the experiment. Nonetheless, it could provide a clear and undiscussed proof for the gravitational shift. In other words, it was not a quantitative detection, but a qualitative observation, the one to grant the result of the experience. That's very important. And as well for us, we cannot maybe quantify exactly how there will be, if there will be really a picometer or less or whichever. But what we expect in tuning the energy of the gamma rays, to observe a variation in the deflection of the gamma rays. So finally, check that this variation could represent, could demonstrate, could corroborate a real interaction between electromagnetic and gravitational forces. Going to the details of our system, of our gem interaction part, we have this depleted uranium bar respecting 2 ρ between the 2 flanges. There are a clash to stop it for maintenance, an encoding and an override controls, and an encoder to check the position of the bar. So this is the next view of the same within the 2 flanges and then the rotating part. This is the tail of the axial loop. But moreover, since we have different parts, 1,000 parts of the depleted uranium that have to roll together to simulate the rotating gravitational field around the beam axis. Those parts have to be aligned one each other, so there will be two encoders at the extreme of each single part, synchronizing with the following part, with the adjacent part. So if we have several parts, we can straddle in, jump several parts, one or more contiguous parts faulting, we can straddle in, use the encoders to check not on the faulty parts but to synchronize on the adjacent parts, and then continue to conduct the experiment having no solution of continuity for the electron. This is very useful trick to grant reliability and continuity for the experiment. Also, the vacuum maintenance of the entire pipe shall be granted by vacuum chambers based on the design of the BSC, basic symmetric chambers, engineered and currently employed for the LIGO experiments, so for the interferometric experiments for gravitational waves. In practical, vacuum chambers will be reduced in dimension adapted to the approx 1.5 meter diameter of the beam pipe, and they will adapt in 9 units, we were mentioning before, to the tetrust structure of the gravitational and or the gem section, the gravitational and electromagnetic interaction section. After the interaction section, we have a magnifier, as we were saying. So the very goal is that, and it's trying to magnify by a factor at least 10 to 4 the deviations of the beam. So we may start from the telescope optics, where the angular magnification is provided by the ratio between the eyepiece angle omega e and the objective angle omega o. So what happens is that, employing a Cassegrain reflector, the optical path will be reflected between two mirrors n times before reaching the focal point. So you get a telephoto effect, creating a much longer focal distance in a mechanically economic short system, because if we expect an eyepiece focal length of 1 meter to have a magnifying 10 to 4, we have to expect an objective focal distance of 10 kilometers. So 10 kilometers is quite a long distance that we could resolve with this Cassegrain concept, Cassegrain reflector concept, plus using as a possible alternative, after configuring Cassegrain reflector, using nested parabolic reflector as a primary one and nested hyperbolic reflector as a secondary one, to get this long path to 10 to 4 meters, so 10 kilometers. The problem would be the distance, it would be the feasibility of the spot, of the equipment. So the possibility is to weld the pipe in a sense that to condense in a space of 10 meters, more or less, this 10 to 4 meters long collimator. So to achieve a magnifying factor of 10 to 4, we demand an objective focal length of about 10 kilometers. As we were saying, we may go around this issue supposing to bend the objective collimator in a spiral coil with windmill-less stretched at the extremities and progressively more wide radius at the center, such to grant maximally linear path for the traveling gamma rays. Finally, the detector. So we have two parts. Why? Because we have still to achieve the goal to be able to detect a variation of single picometer. So the main instrument could be the glass, which is the radar for the gamma ray large area telescope, that is based on the large area telescope LAT, with receive gamma ray power, with receive gamma rays that convert those parts, detecting detecting photons, incoming photons with energy from 20 megaelectron volt up to 300 giga electron volt with a field of view of about 20% of the sky. This is the telescope employed in the glass. The problem is that detected photons are then converted into positron electron-positron pairs. Laue operates in conjunction with a gamma ray burst monitor, GMB, with a sensitivity from 8 kiloelectron volt, that is the range of interest to us, that is, we do remember, for 30 to 130 kiloelectron volt, up to 13 megaelectron volt, which includes tracker and collimator. So with the tracker and collimator, they ought to reveal those electron-positron pairs. The problem for us is that we have to reveal with a better sensitivity. So we have, I mean, the roadmap for the sensitivity of those trackers has to be is expected to increase dramatically up to 2025. But the problem for us is that to get the picometer sensitivity, we expect a dramatic performance soaring based on the electron-positron pair observation performed by alternate detectors, so not a simple tracker and collimator. So the idea is to employ a scan intermission electron microscope to reveal those rays. Practically, in a STEM, electrons are focused onto a fine spot, typical size 0.05 to 0.2 nanometers, by system of condenser lenses, which electrons, so only electrons, not positron. Electrons then pass through scan coils, which deflect them towards upper objective and lower objective pole pieces. Electrons are finally collected into two fields, depending on their angle of incidence with respect to the optical axis, namely the bright field and the annular dark field. The bright field and the annular dark field. So those are the texture in the stem. The stem may grant a 50 picometer resolution, so it's still too high, but the idea is if we use a stem detector with a glass tracker, we'll probably get, this is of course further research, we will probably get the desired expected picometer resolution. In practice, usually a composed detectors in which instead of the calorimeter you use the stem detector after the glass tracker is something that could allow to have a device capable to detect with extremely precision the electrons emitted by the tracker. Then the solar electrons in output, not the positons, the solar electrons in output from the glass tracker could be focused by a stem lensing onto the BF&DF targets of a stem detector. So finally, this would magnify and modulate and output BF&DF images of the incoming electrons such to grant one merged with the glass tracking data the required expected picometer resolution. Man-machine interface. So finally we arrive to the upper part of our hardware system where the operator sits and checks. Practically, we can imagine a suite like that with an operating monitor and the system monitor. The operating display, the operating monitor, could be there, could be more mainly articulated in a live and playback operating mode, as some sub-windows for monitor displaying smoothing. Okay, those are fully detailed in the description of the experiment in the book. What we expect is to control the motor speed of the depleted uranium bar, know about the central mass energy produced at the LAC, and have recording section articulated in blocks of the live and freeze, of the freeze and live images. So we have a live image and we can freeze the image, making some kind of screenshots of the live part. during a current data run. So the operating display has this very peculiar characteristic, just the zoom we emphasize, of the zooming window. Practically you can zoom by click and drag on the freeze on live representation, you can see the freeze representation, and see different level of zoom, practically. In this case, a ratio of 1 to 10 millimeters. In this case, up to a scale of 10 to 2 picometer, angstrom level, 10 to 2 picometers, where finally we should expect to see clear and well-defined plots representing our gamma rays hitting the screen. The operating display is as well a playback section, operating mode, where, all those parts cannot be touched. You can just play back the data run, and you can just see the data run as recorded without any possible manual intervention on it. System monitor display, the other display. This display will check about the status of the entire system. So we have two windows, main and alternate. In the main windows, you check the system status, so the gamma ray source status, collimator fault, target planar fault, radiation hazard around the main pipe, radar status with possible presence of faulty block. You have here the representation of the block that you may scroll up and down. You have 5 flags for each block. If a flag is red, it means that something is recorded on that section of the gem interaction path. The alternate display is this one, where it includes as well the collimator diaphragmal fault, magnified fault, so the motor fault of the two diaphragm, and the encoder status as well for possible force on the encoders on the segment of the interacting section. Problem on the vacuum status on the vacuum chambers, 9 in total, we will remember, and possible tracking status, where we have possible problem of status checks on the glass tracker, stand detector, and Kalman filter. Kalman filter is the filter that elaborates the plots. We shall see this in a short, and as well we have here an error report window where we can read all the faulty messages elaborated by the system sent to the operator. In practical, the software, as we were naming before, is based on the Kalman filter for the smoothing action. So what we expect is to have a smoothing window closing around the plot to let finally identify and follow the plot on the screen. We have two windows based on those two Kalman parameters, and the radius based on as well on these Kalman parameters, Kn. This is the representation of the parameters. An and Bn are the smoothing parameters, the windows parameters that's go to 0, whereas the Kn, the Kalman parameter Kn, is to half for the first two plots, and then goes to 0 with increasing of the quality index n. Clearly is half because you at the beginning set exactly the barycenter between the smoother plot that you have from your FUMA scan and the incoming plot. So the more the smoother plot is reliable, increasing the quality index n, the more you rely on the smoother plot you elaborated and not on the incoming plot that can of course be always affected by possible flickers. The realization we expect a time schedule of this kind where we expect to have a preliminary design review at 4 months, just to check about all the system design documentation, and the critical design review at 8 months, where we expect to first having fixed a tuning agreement for the gamma ray optics, the glass down detectors, and the Chandra X-ray Observatory and the General Gamma Ray Observatory worldwide. We expect to have fixed in agreement with those and a fixed joint undertaking for Gamma Ray Optics Institutes, the glass STEM industries, and as well a common agreement for with the observatories for X-ray, for the Walter telescope, you remember, and the Gamma Ray to, share between CERN or whichever institute and them algorithms about observation and technical detection of gamma rays. So after that, we expect to have production, engineering and production of collimator section magnifier and detector, and to have within the third year, and to have as well within the third year civil work and refurbishment of all the parts completed. We expect then as well in the control room to have hardware installation and set up within the fourth year, and we expect as well the same for the control room and installation and setup, and we expect as well within the fourth year to have a simulator, to have developed a simulator and check and develop and check all the software needed for the system. This is the procurement of the procurement of the installation setup of the control room. So at mocap ready, we finally can begin to integrate the system, and we expect to have it ready for data run within the fifth year. So, an ambitious program, but quite costly in terms of investment, but a program where we expect to finally have the chance to discover, to reveal, to detect an extremely important law or nature, the one ruling the interaction between gravitational and electromagnetic forces. All these parameters, just to let you know, under patent request by the Ministry of Economics, also the Ministry of Economic Development in Italy. The patent has been requested on January 2021. Conclusions. What we have seen is that we have to expect a leading order interaction as well for really the very experimental Leibniz deflection, and the next to leading order term ruled by this U cube term. This provides the famous 1.75 second of deviation, but using now I began to play as well with math this time, and imagine a possible quantum approach and a possible interaction based on a Feynman principle, quantum Feynman principle of interaction between a propagator and two tensors, the electromagnetic tensor and the gravitational energy momentum tensor, the electromagnetic and gravitational energy momentum tensors. With this propagator, what we could have? We could have a next to leading order interaction. So the famous correction, grading our experimental data, the one set by Eddington, and after that, after the 70s, final 60s, 70s, using the microwave detectors, check about this possible next to leading order result that could give a rationale for this extra deviation that we have increasing progressively with the energy of the electromagnetic beam. So, what we could imagine, what we could finally figure out, and just continue to speculate on this, that starting from electromagnetic fields, we can fix, as for the electroweak standard theory, an interaction between currents of QED, so electromagnetic, and currents due to weak interactions correlated to the Z nu field, that is the Z0, the zeta 0 weak boson, weak intermediate boson. But we have as well with QCD, we saw before, right, talking about our experience, in which the X particle this propagator is something like relating the action of T quarks with weak intermediate W plus or minus bosons. The two, of course, are correlated because now the Higgs that Bohr find is Bohr inside electroweak theory as well correlates interactions in QCD, in quantum chromodynamics, so as well an interaction, a liaison between electroweak forces and quantum chromodynamics forces. But with what we just proposed before, I proposed before with the quantum gravitational approach, the possibility to correlate electromagnetic and gravitational forces via this interaction term, in which this propagator contracts with these two tensors, the electromagnetic one, the energy momentum electromagnetic one, and gravitational one. With this, we are called propagator term. So practically, what we can play with this, that cancelling and just leaving the diagrams, you get this, that we could call the Maclave's diagram. So a diagram that is possibly correlates all those forces. This is not a grand unification theory. This is just a proposal, this is just a vision in which those forces are somehow correlated by the electromagnetic one as the central part, the barycenter of those. It's not a unifying theory, it's just a theory where, a model, a theory proposed where this possible interaction could be revealed and could be detected, such to grant a new page for physics, clearly, that is the interaction, the direct interaction between electromagnetic and gravitational forces. Well, that's really all, folks. Those are the reference to the books I mentioned during the presentation and my mail addresses where you can write for comments and proposals, ideas, and as well to request to me and end out with the presentation. So that's really all, folks. Thank you especially to all that had the courage, the guts to follow me so far up to this very, very long, very complex presentation. And again, thanks. See you soon. Cheers.